Welcome to Introduction to Programming Lecture 7. Today we will see object-oriented programming. What is it and its characteristics, then advantages. Then we will see the basic topics: encapsulation, inheritance, polymorphism. Then we'll see a test plan. You will have to make a test plan in the assignment, and then we'll see the assignment. So what is object-oriented programming? It is oriented around objects. Our name specifies that. Design of software around data or objects. I mean, we design our software uh, around the data, okay, rather than functions and logics. Uh, we get into that later on, but first we see the objects. Well, anything can be object. A cup can be object. A person can be object, or any animal or anything can be an object. So an object can be described as data fields having innate attributes. Uh, well, basically, we design a class which is a blueprint for object. We would use a class as a blueprint for the object. It is programming. Well, it is designed around the objects, as the name specifies, object oriented. Well, it is oriented around the objects. You see, we'll design our software around the objects rather than we design it on functions and logics. Well, we get into functions and logics, but first of all, we will see the data around which we will build our logic. Okay, so we use class. We divide like objects into classes. Classes is basically like a map on which we build our objects. So a class can be anything that have unique attributes and behavior. So these are the building blocks of OOP. So first of all, we have classes. These are the user-defined data types. You see in different languages, we have different type of data types like integer, string. I hope you are familiar with data types. So these classes are user-defined data types. They can be anything. So they have methods like anything that implies on that data or the behavior, you can say what a class can behave as. So these are the methods. And then we have the attributes. These are the properties of the object, the class. Here object is an instance of class. So if I use classes or object, they sort of kind of mean the same. So any question up till now in this slide?
No, sir.
Okay. Well, here is a graphical representation of what we just saw. Well, class human is a class. So objects, what would be an object? Like, it can be anything: name, ID, if it's an employee, or anything CNIC number. So this is the methods that can we can include in class. So we can have if the class human have email as its property and address as its property, we can use the methods verify and send mail and so on. So this is the code example of this. So I defined here is a class human. These are the access specifiers. Uh, you will understand them as we go far. So these are the properties, the name, email, and address. These are the attributes. Okay, this is a function. Well, this is a special type of function. It is known as constructor. Every class should have one constructor. So this is to just to initialize its attributes. Well, this is the function method. which can be defined inside this class. So what this function do is just prints the data that it has there, whatever object we initiated. So it will only print that data on the screen. This is what this function is doing. So here we have an example of using that human class. So we pass this as an parameter. You see this here we have defined this constructor. Okay, so that's why we were able to pass these parameters to this object. Okay, we saw this that here we have a class human in which we have the attributes and methods. Here we are using that class. We are initiating its object and then we are calling its function that we defined inside the class here. So here we are initializing it again, and then we're doing the same. Notice that in the output we have a different output because we passed the different data. So, well, advantages of OOP. Well, there are a lot of advantages using object-oriented programming. Well, the few of them are here. Reusability. You see that here we by just passing different data, we were able to get different outputs by calling the same function. So this is an example of reusability. Well, we avoid the redundancy. Redundancy is repetition of something, so we avoid that. And code maintenance is very easy. If I were to go back here and just change the implementation of this function, and I won't have to change all of the function here, and the output would be according to that. So code maintenance becomes very easy. Well, it is secure. We saw that here public. Well, if we just replace this with a private, so these all the attributes would become private, and the other objects cannot access them. So it would be very secure. And we have other design benefits like in object oriented. You see, designing anything is easy, and there are a lot of other benefits, design benefits. As you will go advanced, you will see a lot of design benefits. Well, it is easy to troubleshoot. Like if I am getting any problem in this function here, so I would just see that okay, I'm getting problem maybe here. So I would go into the code, see okay, here I call the function, so I go directly into the function. You see the tracking becomes very easy. So the troubleshooting becomes very easy. Well, these are the characteristics of OOP, encapsulation, inheritance, and polymorphism. Well, what is encapsulation? In simple words, it is just hiding the code. As we saw here in the example here, you see the main implementation is here. But when we call the function, we don't write the entire code again. Okay, so we don't know what the main logic is behind this function. So we are just using it. So this is encapsulation. We encapsulated code from outer logic of the program. So this is the encapsulation. And we can select what information is exported using access specifiers like public, private, and protected. Implementation instead of objects are privately and kept inside the defined class, while the code and the implementation is stay inside the class, doesn't get out. So we can just use it. This is an also example of reusability. The system becomes secure using the encapsulation if we only export limited code. Like, for example, if some function is dealing with passwords or something, so we do not export that kind of program. So someone else won't be able to change the password without using our system. So any question from encapsulation?
No, sir.
Okay, this is an example of encapsulation class. We have class animal here. You see this private, this is access specifier. It has name, public, animal. These are the functions. So here we are using this class. And again, this is the same example, animal dot make sound. So this is the output. It is making sound. It is printing, making sound on the console. So we don't know what this function is implemented in this function, how it is implemented, and what line of codes are written in that function. We're just calling it, and it is giving us our desired output. So this is
Sir, in the beginning, it's written class animal and it's written private.
yes,
So that the private part is only available to the one who made it, and the public is open for public. Is it like that?
yes. For example, here we have an other class human. So a human class cannot access this name directly.
And they can access the public part directly.
Yes, this is the main access specifier thing. Like if something is public, other classes and objects can access them. And if it is private, only that class can use it. Or we would have to like see here. I am printing, sorry. Uh, Here it is not written. For example, if I wanted to read the value of this name, okay, I would go into public and define a function where I would pass this value to external objects. Okay, so that way I can access the private parts, but still I would have to use the code of this class. I hope it's not too confusing.
Yes, sir. It's okay. Got it.
Okay, great. Then we have the inheritance. Well, basic reuse of code from other classes, like here. You see, we use the defined function. But not only that, we can also use the uh, like properties and other methods as well in inheritance. But of course, if they are private, we cannot use them. If we inherit a class, they had to be either public or protected to allow another object which inherit that class to be used inside them. You see, for example, we write like 1,000 line of code, and then we need a class which only requires a little bit of alteration in the code, and the rest of the code is the same. So what we do, we inherit from the class in which we have written our initial code. Then we change whatever we want to change in that new class. So we won't have to like write again 1,000 lines. So this is an example. For example, we have a class animal, and then we have a class which is named as cat. For example, a cat has a name or owner. It's a pet, so different attributes. So animal, you see, cat is an animal, so it shares most of the logic or making sound function. It can share with that. But you see, not every animal makes the same sound. So we inherit from animal class, and we just only change the required function. So a cat can have its own sound. See that common functionality will be shared, like sound, kingdom, etc. Same functionality will be shared, and we can alter the code as our requirement. So the class that inherits code from other classes is known as child class, and the class from which we are inheriting known as parent class. Here's a code example. Well, here in this case, animal is a parent class as it is being inherited. So cat here is a child class. You see that all of the code is here, but if we call the function here, it would also work. The word polymorphism means having different forms. So we design objects in a way so that they can share behaviors, just like we saw in inheritance. But in all the cases, we cannot just go for the inheritance. Like car is not an animal, so we cannot go for inheritance in that case. So a benefit of polymorphism is to reducing the need to duplicate the code. Of course, this is the one of the biggest benefit of using OOP. So again, the child class can redefine the methods the parent class methods of the parent class as needed. Like for example, if animal we have make sound. So not every animal have the same sound. So in cat, we would override the code in which we would give the cat its own sound. It also extends the functionality of our program. So this is the example of polymorphism. Like for example, there is only one class animal, and then we have different animals. So every animal have their own no, voice. So whenever we define a class, so we also override its sound function so that every animal can have its own sound. Any question from polymorphism?
No question.
Okay, well, this is a sort of combined example. Here we have animal class. Class cat is inheriting from animal class, and we are overriding the method here. See that? This is the same method. So we inherited the properties that we needed from parent class, and we are overriding whatever we need. So in the main, you see, if we run this, the output would be whatever we pass here. Okay, name of the animal. But you see that in the cat, it makes its own sound. You see, the override function will be called. Then you would have to make a test plan. Well, in test plan, you can also follow the IEEE standard. It will be available on the internet. You can download the template from there, or you can. I suggest you follow that. Okay? So here, test plan would include test plan identifier. It's just the identifier, or just like the number we have a CNIC number and different number. It can be anything like test plan 1, 2, 3, etc., and so on. So then we would have introduction. We would write introduction in that test plan about the product that you are building, or and about the test plan, then what features you are going to be testing in that uh, testing phase. Then you will write the features that don't need to be tested. Then you will make test cases. We saw that in computer programming course. Uh, we had a whole section for that, test cases and how to document test cases. Then you would write about the test environment, and then approvals. Well, in professional environment, we need approval from a lot of people like stakeholders and people who are monitoring our project and so on. So you would create a test plan. Okay. Well, these are the main topics of. So now we'll move from assignment. Any question from previous topics?
No, sir, no questions so far.
Okay. So mm, we'll see assignment. Uh, do you have a copy of this?
Yes, sir.
Okay, I'm sure you have already read this. So we'll
Yeah,
move.
yes, I have gone through all this.
Okay, I'll move forward. So here in task one, you would have to produce an information document. Okay, describe how computer programming languages are used to meet business needs. Well, this is all theory. Uh, if you have any question from any of this, you can ask me. Okay.
No, sir, from theory, I don't have any questions,
Oh,
but the practical part,
okay, okay. In implementation, okay.
the writing a program, because I have never done anything like this before.
You have never written any program?
No, no, this will be my first time.
Oh, well,
So that's why I need a little bit of your help in the writing this program.
okay, okay. Well, I cannot like show you how to write program in this lecture, but we will discuss the how to write program. Well, first of all, you would have to identify the problem that you're going to solve for the store. Okay, and then you would develop the program using C++ language. Well, in the implementation, I guess you would have to do it on your own because I cannot share solutions with you. So, you would have to develop a program according to the requirements. Here you have the requirements. Okay. You will get the requirement from this paragraph. We are required to build a program for a home furniture retail store. Well, the program must be able to allow the store to manage all the aspects of their stocks. Well, this include entering new stocks. Well, your program must be able to enter a new stock. Okay, and then if someone want to allocate that stock, then your program should be able to allocate it as well, or add a new stock or allocating an existing stock. And you would also generate reports. Well, I guess it will be like a console-based program. You won't be able to implement like GUI into this. Well, in the course content, I don't think they mentioned that I would have to show you the like teach you a language or something. In the course content, I would only have to cover the topics that were mentioned in it. Okay. Uh, so you don't have any question in task 3 and task 4, okay?
No, no, this is just the theory part. That's all. Because theory, sorry, the practical part.
Okay.
Theory part I can do.
Okay. So you want me to show you some basic coding examples and that?
Yes, that might help, but related to program this assignment. Or can you have one full class for this assignment? Is it possible?
Uh, well, I cannot show you the like solution to this program, but I can have a different class for the, the coding, in which I would show you how all these things work. Like these, you see, I included these topics in this because I was told to go over the OOP, and I know that most of the people are not comfortable with OOP directly as first experience. So that's why I included these topics. I can show you the implementation of these. Okay, so you would go into files and then new, and then here you would create the project. So we're building a console-based project. So here we would select the console application. So hit go and then next. So we are building C++ program. So we would have to select the C++. If it's C is selected, you would have to select C++. Okay, go next. Here we would write the project title. And so here you can select the destination in which your project will be stored. So hit next. Uh, Leave the options as they are. So here we go. It is building our project. So in the source, we have this main class. Okay. So this will write the basic structure of the program. Here is the build and run command, and this is the run. So every time we change our code, we would have to build it and then run it. Okay. If we run it, it will run the last successful build. For example, if I get an error here, so it will not detect that, it will run the last successful build. In this case, we haven't even built any program successfully, so we would have to build it. So it would take some time, and here your first program, which is outputting on the console hello world. Okay, so this is the main program. Well, the compiler first goes and looks for this main function. Wherever it finds the main function, it will start its compilation of the program from that function. So we can define our classes here. Let me just go and copy the code from our example. Okay, if I instance, if I create the instance of this class here, let's just not waste our time on writing code again and again. Okay, it is giving me error. I don't know what the error is. Oh, well, last time I tested it, it was working just fine. Let's try to run this without that. We'll see what the error is. Uh, okay, I don't know why this is giving so many errors. I tested it last time. It was working perfectly fine. Okay, we will write the code again. Oh, now it's working. Funny. Okay, let's compile this. Still working. You're getting what I'm doing, right?
Yes, sir.
Good. If you have any question, you can ask me.
No, sir, no question so far.
Do you know what this is? This is
This is class, I think.
okay. What it do?
It gives the name.
A little more. Elaborate a little more.
Like suppose if it's human, so you give a name. If it's an animal, the name. So they specified name.
Okay. This is a reference to class itself. Okay. See that I'm using the same variable name here.
Yes, sir.
So uh, uh, to tell the compiler that to make it not get confused, we use this. So it means that we are referring the attribute of the class, not this local variable. That's why I'm using this. So let's keep running it. Okay, it is building successfully. So here let's wait, and it takes name. Okay. Well, I'm doing pretty much the same as the example from our lecture. and it is running. I don't know what was the problem in that example. So let's create a function here. And details that would print.
So what is void here? For the
Okay. This is the return type. You see, here we have integer return type, and every function has a return type. So void means nothing. We are not returning anything from this function. So that's why here I have void. For example, if I was returning a string from it, I would write string. Okay. So let's return this dot name. Okay. Instead of just printing it, we are returning. So here in C out, we would call this function. Okay, we give this a name. It requires a name. H dot. Okay, see that a name. Is it visible?
yes, sir.
Okay, good, great. So if I am returning the string, I would have to. I can call it like here, but when I run it, you won't see the value returned from this. Okay, see something. Okay, yeah, you can see the ABC, but its value is lost. We would have to store its value into some variable, or we would have to write it inside the C out because it is returning something. If we implement this the old way with void C out, in this name, then we won't have to like store it into any other value, or it is still running. See, the name gets printed directly because we are printing it inside this function. So let's say we have a class calculator here. So you see how I am commenting these lines? Do you know what comments are? Uh, I asked, do you know what comments are?
So for comments, we use slash. Comments are for letting us skip.
Well, comments are, hints or reminders for us. Or
For us keeping a record for a specific
yes,
command
yes.
that we get.
You saw that I didn't erased all the logic here. I just commented it out. So, well, it's a good practice to.
These comments won't run, they will just stay here for our reference.
Yes, yes, exactly. So, well, it is also, you can leave notes for yourself. So, you can, just write a description for what this class does. Okay. So that way, when, right now, if we write like, a 20 line of codes or something, well, if we come back to it like in after 20 days or like a month, Well, we can still kind of sort it out what we have written. But imagine you have written like hundreds of lines of code. So after a while, you will forget what you have written. Like right now, I can tell that this is constructor. This is a function. What it does, it prints the name of this class. So well, it's easy. But uh, when code gets big, things get kind of messy. So what would you do? You would start adding comments for you later on.
Yes, sir.
So that's how you can explain your program as well, and still keep the clean code. So this is, I think, one of the requirements of your assignment, that you would have to explain your code in comments. So that's how you do it. Either you write it on top of it or in front of it. You can also write in front of it, anything. Okay, well,
Yes,
this
sir.
is a single line of comment. Okay, a single line comment. And for multi-line, you would do something like this. You see, all of that just turned into comments. Now it
Yes, sir.
also requires an closing. So here you can write anything. So it would be multi-line comment. So you see that here, if I just press enter and start writing, this is not a comment. So a compiler thinks that this is something that it should compile. So that's how you explain your program and add
So
comments.
if we're writing a paragraph of code, does it have any specific limit of words, or we can just write how many words we want?
No, there's no limit. You can write as many words as you want. Like, for example, are you asking with perspective of comments or
Yes, in respect of
program?
comments, yes.
You can write as many as you want. There's no limit. Okay, I was going to give an example of calculator here. Let's just say we have a sum. You see, I wrote int there because
Integer.
yes, I was planning to return an integer. So, well, this whatever this function receives, we write here. So it receives one integer. It should have a name. So if you receive a second integer, it should also have a name. So what it returns the sum, as the name suggests. So return a plus b. So if I comment this out, I'm calling this sum. First of all, I would need a calculator object, and then c dot sum. Let's see if it works. Okay, it's private. Okay, you see that it gave me an error that it is private, so it cannot be accessed by any other class. See that? I was trying to access it
Yes, sir.
outside of the class. So I would have to write a public here. So now you can see the result here is 3.
Yes, sir.
Let's make it a little more elaborate. We can enter any number here. You see the sum is 8.
Yes, sir.
That's how you can use other classes, and you can play around with the code. Okay, any specific example you want me to show?
No, so it's kind of clear now.
Okay.
I'll try to practice it tonight. If I have doubts, can I text you in the group?
Yes, okay. You can ask any question in there or anything. Okay, is it enough or should we see one more example?
So I think it's enough. If I have any further questions while doing practically, I'll ask in the group.
Okay, no issue. So if you don't have any question, I think we should end our session today.
Yes, and no questions so far.
Okay.